All right, so here we are in chapter 1 on ingredients of change, functions and limits, and we're in section 1.7, constructed functions. So let's start with some terms from business and economics. We have fixed costs. Now these are costs that remain constant no matter how much merchandise is produced, and that could be your rent or electricity or whatever. Variable costs, those are costs that change depending on the number of units produced. The total cost is the sum of fixed cost and variable cost. An average cost is the total cost divided by the number of items produced. Our revenue, that's the product of the selling price per unit and the number of units sold. Our profit is the difference between revenue and cost. And then we have a break-even point. That's the point at which total cost is equal to the total revenue. And this occurs when profit is exactly zero. Okay, so basically your break-even point, your profit is zero because your revenue and your cost are exactly the same. All right, so this is from the book, but I kind of want to go through it and just explain it a little bit here. So we have this company called Party Fun Inc., and they manufacture and sell inflatable slides and bounce toys of the type used at events such as festivals and children's parties. So they have the fixed cost. The annual fixed cost is $90,000. That includes your rent, your utilities, your maintenance, your insurance, your salaries. And so that is fixed no matter what year it is. Okay. Now the variable cost is 600. And that's to produce one inflatable moonwalk castle. All right. So that's all we're worried about now. We're not worried about all these other things. We just are looking at that one moonwalk castle. And then we have the selling price for that moonwalk castle, and that's $1,800. So what we want to do is with these items, we want to start creating some functions. So the functions we're going to create is kind of the ones we just looked at the first page here. We have fixed cost. Well, we'll call that f of x for fixed. And that's just going to be 90,000. That's all it is. It's just 90,000. And x is going to be the number of moonwalks castles produced there. And since we don't have any difference in change there, we're not really going to have a difference in what our fixed costs are because they're going to be fixed. It doesn't have anything to do with a value. So even though we're saying x is the number of moonwalks produced, it could be f of 5 and it's still going to be 90,000. It could be f of 1 and it's still 90,000. Okay. Now, variable cost. To produce X inflatable moonwalk castles, we said each castle costs $600. So it's going to be the variable cost is 600 times X, depending on how many we make. Now, the total cost is, now we're going to add the fixed cost plus the variable cost. And so the total cost for that number of castles X is going to be called C. And that's going to be 600X plus 90,000. So our variable cost plus our fixed cost. So that's kind of like our b-intercept and our slope. And then we have an average cost to produce 200 castles. Now, when we do average cost or average revenue or average anything, we're going to put that bar over it. And so for the average cost, we're going to say C bar of X. And that's going to take the cost of 200 of them and divide by 200 basically. And so we're going to have to plug in 200 into this equation, get a value, divide that by 200, and that will give us the $1,050 per castle is our average cost to produce 200. Now, if we produce 400, that's going to change. But for 200, that's what our average cost will be. Now, our revenue from the sale of X Moonwalk castles is modeled by $1,800 times X because it says we're going to sell them for 1,800. So if our revenue is going to be 1,800 times however many we sell. Now, our profit. Now, let's say we want to go back and say we want to sell 200 of those. Our profit is going to be P of 200 is just going to be our revenue minus our cost. And we have to plug in our 200 and 200 and get our values. And then we find out that's equal to $150,000. Okay, so again, we're just plugging in 200 for R, 200 for C. So here you put 200 here in, get that value, 200 here and get that value and subtract them, we get $150,000. Okay. Now our break-even point, remember, that's when the revenue and our costs are equal. And so R of X minus C of X is equal to 0. When is that equal to 0? Well, that's when X is equal to 75. So once we hit that 75, we have revenue and total cost equal at 135,000, and we can plug that in and solve for it and get it. And then that's what it is. But the way we'd most likely do it is we take our R of X, 1,800, minus our C of X, which is 600X plus 90,000, set that equal to 0, do the simple algebra, and we get that x equals 75, okay? Now here are some illustrations they show in their book of all the different places, pieces. So in 1.69 here, we have the C of x, we have our f of x, and we have our v of x. So variable cost, fixed cost, and our total cost. Okay, and so basically when we add those two together, that's what we get for the cost function. Now the average cost is going to be this, and so basically we're taking our total cost divided by however many we make, and we can see that that's going down like this. So it's kind of an exponential function. And then we have our figure 1.71. These show the break-even points as the point where the revenue and the total cost are equal. So our total cost goes this way, our revenue is going up like this, and where they cross, that's where they're equal, and that's where we got that $75 here, okay? And then this is our profit, our P of X, and so that's going up, and that's where we hit 0. And then beyond that, we're actually going to gain a profit. Before that, we were losing money. Up to that point, we hit 0, so then we're break even. And then after that, we're gaining money. So these things should be all familiar from your economics or business classes. And we're just going to be applying them to functions in our class, okay? All right, so I'll pause there and I'll come back with the next section.